Sup, Topher? Welcome back to the show of anatomical analogies. It gets better and better every sip. But in this video, we're going to discuss the structure of myofilaments. So myofilaments are comprised of primarily of proteins, two specific types of proteins. So there's contractile proteins and regulatory proteins. First, I love when you get hair in the mouth, But first, contractile proteins, there's two types, actin and myosin. Actin is thin filament, myosin is thick filament. And when the actin and myosin intersect, that's when the muscle contracts. So that on the actin, there's myosin binding sites, and on the myosin, there's actin binding sites, and we'll see why here momentarily. But contractile proteins, actin, which is thin filament, and myosin, which is thick filament. There's also regulatory proteins, which regulate the interaction between actin and myosin. So this is what determines if the muscles relaxed or contracted. So regulatory proteins determine that interaction between the actin and the myosin intersecting and essentially contracting the muscle. But there's two types of regulatory proteins as well. There's tropomyosin and troponin. So tropomyosin wraps around the actin, covering the myosin binding sites. We mentioned the myosin binding sites and actin binding sites up top, but the tropomyosin wraps around the actin, which covers the myosin binding sites. And think of this like a string that covers the sarcomere on the outside. I'll show you all a picture here in a second. Then the troponin actually holds this tropomyosin in place. So think of the troponin as think of it like an anchor that holds the string or the tropomyosin in place here. So we're gonna look at a picture here. So I hope you all can see that properly here. So this is gonna be the thick filament. So this is thick filament. This is the myosin here. On the inside, here's the actin, all the way around here. And those little dots in the actin, that's the myosin binding sites. So these little strings here, I'm gonna draw it again. There's a string, and this is just a visual representation. So there's a string there. So this is the tropomyosin because it covers the myosin binding sites of the actin. And then here is going to be the troponin, which holds this tropomyosin in place. So we got the thick filaments, the myosin down here. Thick filament. Got the actin with the myosin binding site. Tropomyosin wraps around these myosin binding sites. It's like a string that covers them. Yeah. You guys can see that still. Then we got the this little anchor here, if you will, holds the tropomyosin in place. So the troponin holds this tropomyosin in place here. And then really cool thing happens. So the troponin obviously binds to the actin, but troponin also it has a stronger affinity to calcium. So what happens is this get the image here, the visual representation. So use a different pen. So obviously this tropomyosin covers the myosin binding sites of actin, but the troponin, so this troponin here, it'll bind to calcium out here. So it jumps off of the tropomyosin, binds to this calcium, and then this tropomyosin, it doesn't have the troponin to hold the tropomyosin in place. The tropomyosin will slip off of the myosin binding sites and making them exposed. So they won't be covered. The myosin binding sites of the actin won't be covered when the tropomyosin slips off due to the troponin binding the calcium. And guess what? This myosin then, since the myosin binding sites are exposed, this myosin here can bind to the myosin binding sites of the actin, and then that interaction pulls this thin filament, this actin, closer towards the middle of the sarcomere, causing greater overlapping, ultimately causing contraction. So once again, the tropomyosin covers the binding sites on the actin. The troponin then binds. This is in muscle contraction. Here's how muscles contract. So the tropomyosin covers the binding sites of the actin. Then the troponin binds to calcium, which is actually stored in that sarcoplasmic reticulum. So that's where that comes into play. The calcium gets released from the sarcoplasmic reticulum. Troponin binds to that calcium, and then the troponin can't hold those tropomyosin, those strings covering the myosin binding sites, in place, and the tropomyosin then slips off of the myosin binding sites of the actin. Then the actin and myosin can bind together. Myosin pulls the actin towards the center of the sarcomere, which causes greater overlapping, which ultimately causes muscle contraction there. So the more calcium that's available, there's going to be contraction. The less calcium that's available, it's going to be when the muscles relax. And yeah, we're going to go through the full process of the muscle contraction in the next video, but this gives us a basic foundation. So see you soon.